Hey everyone, let's dive right into this explainer and actually follow the money behind the massive AI boom. We've all seen the flashy headlines, right? But today we're going to look way past the hype and dig into the actual macroeconomic reality here. Is the foundation of this whole industry really as unshakable as we've been told, or is there something else going on?
$450 billion. Think about that for a second. That is the staggering amount data centers are projected to spend on AI infrastructure in 2026 alone. And get this, almost this entire tidal wave of capital is being dumped straight into hardware, specifically high-end graphics processing units or GPUs. So, with this absolutely historic level of capital expenditure happening right in front of us, we really have to pause and ask a critical question. Is this trillion-dollar compute race actually grounded in real economic returns? Like, are the companies hoarding all this hardware actually turning a profit, or are we just witnessing a massive circular illusion? Well, to figure that out, we need to start by looking at the actual price tags.
Section 1. The GPU hardware premium, the real cost of compute.
The heart of this hardware frenzy really comes down to one thing: the margins. Take the industry standard NVIDIA H100 chip, for example. The actual physical cost to manufacture that thing, like the bill of materials, is just over $3,300. Yet it retails for anywhere between 25 and 40 grand. That's a gross margin of up to 89%. It's wild. Even the next generation B200 chip, which costs about 13 grand to make, is commanding a retail price of up to $70,000, mostly because of these severe market shortages. And you know, the spending absolutely does not stop at that massive initial purchase price. The hidden operational overheads are just staggering. Just one of these chips can draw up to 1,000 watts of peak power. And because they run so insanely hot, data centers are forced to spend between $15,000 and $100,000 just on specialized liquid cooling for a single server rack. I mean, you're basically buying a luxury car just to keep the computers from melting. Top that off with hardware that depreciates at 15 to 20% every single year, and simply keeping the lights on becomes this massive financial burden.
Section 2. Inside Circular AI Financing, the House of Cards.
So, this naturally leads us to a pretty glaring question. If these chips are so wildly expensive and lose their value that fast, how on earth is anyone actually paying for them? Well, the answer lies in a rather dangerous macroeconomic mechanism called circular financing. Instead of funding these purchases through, actual organic consumer demand, the major players, so the hyperscalers, the venture capital firms, the chip makers themselves, they're essentially just passing the exact same money around in a continuous loop. They pull this off using complex asset-backed debt and special purpose vehicles, or SPVs. Now sure, that isolates risk on paper, but ultimately, it just artificially inflates the entire market. Let's actually walk through how this shell game plays out step by step. Step 1, a massive tech company, a hyperscaler, commits billions of dollars in computing contracts to a smaller neo-cloud provider. Okay, then step 2. That neo-cloud takes this guaranteed contract straight to a bank to secure high-interest, non-recourse debt. And finally, step 3, they use that borrowed money to buy more GPUs, which act as the collateral to feed right back to the hyperscaler. The crucial takeaway here is that these tech giants are essentially funding themselves through shell vehicles. They're completely bypassing the need for real outside demand.
Tech analyst Ed Zitron actually captured the sheer absurdity of this potential oversupply crisis perfectly in his tech report. He asks, is this industry capable of doing anything that isn't circular financing? It's a great question, because if these major tech companies just keep renting out capacity to each other to fuel unprofitable AI labs, they're actively masking the reality that there just simply isn't enough real-world demand for all this compute power they've built.
Section 3. When agents burn budgets, the enterprise disconnect.
So, what happens when these incredibly expensive systems finally hit the real corporate world? We are seeing a severe clash between the narrative and the actual math. The utopian promise, of course, is that cheap, autonomous AI agents are going to seamlessly replace human workflows and save corporate budgets. But the reality? It's kind of a nightmare for accountants. Uncapped agentic AI, where systems autonomously orchestrate tasks and read through entire code bases, it creates this non-linear explosion in token consumption. Unlike a static software license that you just pay for once a year, this usage-based consumption is instantly draining corporate budgets.
A highly visible and honestly pretty shocking example of this is Uber. They rolled out Claude Code to roughly 5,000 engineers, right? Well, by March, 84% of those developers were using it heavily. And by April, literally just 4 months into the year, Uber had completely vaporized its entire 2026 AI budget. The usage doubled in a matter of months, the token costs spiraled completely out of control, and their CTO had to publicly admit that they needed to go back to the drawing board. And if you look at Gartner's data, it proves this is absolutely not an isolated incident. An overwhelming 89% of AI agent pilots never even scale beyond the initial proof-of-concept stage. Enterprises are quickly finding out that these systems are just way too expensive to run at scale, they're too complex to integrate, and they really lack the necessary risk controls. So we're left with this massive echoing gap between the $450 billion being spent on hardware and the actual successful deployment of the software.
Section 4. The macroeconomic reality check, trading humans for hardware.
This brings us to the final and most sobering reality of what this bubble is doing to the broader economy. Honestly, this quote should probably be pinned to the wall of every single boardroom that's currently planning an AI transformation. Brian Catanzaro, the VP of Applied Deep Learning over at NVIDIA, plainly stated, "For my team, the cost of compute is far beyond the cost of the employees." I mean, when an executive at the exact company selling the picks and shovels for this gold rush openly admits that the shovels cost more than the miners, we have a deep structural economic problem on our hands.
Yet despite that mathematical reality, companies are still aggressively cutting jobs in the name of AI efficiency. We're looking at over 70,000 AI-attributed job cuts in 2026 alone. But here's the kicker. The macroeconomic data proves the financial returns are virtually non-existent for these headcount swats. Gartner actually found that companies making deep cuts for AI see identical or sometimes even worse financial returns than their peers who just kept their staff. On top of that, rigorous MIT data reveals that current AI systems are economically viable to replace human labor for only 11.7% of the workforce. For the remaining near 90% of jobs, paying a human being is simply cheaper than paying the astronomical token costs of AI agents. Which leaves us with a pretty profound question to chew on. When is the market finally going to reconcile this futuristic, autonomous narrative with the cold, hard financial numbers? Really, how much longer can this circular house of cards actually stand, fueled by all this high-interest debt and inflated hardware costs, before the enterprise budgets just dry up and the bubble finally bursts? Thanks for joining me on this explainer today. I really hope this gives you a much clearer view of the actual economics driving the AI industry right now, and how all of this might impact you tomorrow. Keep an eye on those numbers.